thermochem unit, you learn about calorimetry, and we're going to use the formula NH equals negative MC delta T, which you use for any calorimetry experiment. We'll get into this a little bit more, but what we should know already is the left-hand side is about the reaction and the right-hand side is about the water. And if you do not see water directly, then we have to think, what would make water? And that's why we're going to, in particular, look at a neutralization reaction when we have to imply what's making the water. So with this example, we see that it is a neutralization reaction, gives us some information about the potassium hydroxide, and it's reacted with hydrochloric acid. So we know it's a neutralization reaction, and with a neutralization reaction, when you mix an acid and a base together, you are going to make salts. Oh, I'm not sure why that's not coming up that nice. Salt and water. And that's what's going to matter here is that water. So when we fill in that formula, NH equals negative MC delta T, that we realize that the mass of the water is coming from this reaction. So the acid and the base together make the liquid water, and that's what we have to account for here, add the acid and the base. So if you're doing questions like this and you're not getting it right, it's probably because you didn't add the masses together, because that is the most common mistake. So we are also given the initial and final temperature, and we want to know the molar enthalpy of the neutralization for the potassium hydroxide. So we have enough information to figure out the moles of potassium hydroxide. We're solving for H within this question, and then this information about the water, we'll know the mass of the water, we know the specific heat capacity of the water, and we'll be able to figure out the temperature change doing a quick calculation. So the left-hand side, because it's asking you about the potassium hydroxide, that is going to be the KOH information. And again, the right-hand side is about the water. And if you don't have water directly, then like this question, what makes water is the acid and base together. So let's go ahead and start setting this up. So if it's about the potassium hydroxide, to get to moles of potassium hydroxide, we can take our milliliters or our volume and divide it by 1,000 to turn it into liters. So we'll have 0.075 liters. You can multiply this by the 1.0 mole per liter of the potassium hydroxide. And so here liters will cancel, and now we'll have moles is what we wanted to solve for. We want to figure out H, so we'll get there in a moment. And then on the right-hand side, we're going to have our mass, and that is in grams, and 1 milliliter will equal 1 gram. So we're going to take the 75 and add it with the 100. So we'll have 175 grams. And then you want to multiply this by the specific heat capacity, so 4.19 joules per gram degree Celsius. And then we'll multiply this by the temperature change. So 32.2, and we're going to subtract 25.1. And the set temperature change of this experiment is 7.1 degrees Celsius. So at this point, grams was here. You'll see that just in terms of units, we'll have moles on the left. On the right-hand side, grams will cancel, degrees Celsius will cancel, and you'll be left with joules. So let's go ahead and isolate H. So on the right-hand side, multiply all that together. So negative 175 times 4.19 times 7.1. And then we want to divide it by the moles. And if we went 0.075 times 1, we're just going to end up dividing by 0.075. So here, if you plug this into your calculator, you'll see an answer for H is negative 69,000. Sorry, my leg of the pen here. So 69,414, and then we have our decimal 0.33, and this value will continue. I'm not sure why this pen's acting like this. And that would be our H for molar enthalpy is joules per mole. Now, if you take a look at our options, it's all in kilojoules. So we can go from joules to kilojoules by dividing this by 1,000. And let's do that. Sorry, 1 second. Take our answer. Oh man, I just got that to move. So we're going to divide that by 1,000, and you would see that it would work out to negative 69.4 kilojoules per mole. That's a K, kilojoules per mole. You just can't tell. So that is our example here. You can double check a few things. The fact that your temperature is increasing, it should be an exothermic reaction. So your delta H should be negative, so which it is. And that also means you could have ruled out B and D to begin with. The distractor would have showed you if you didn't add the volumes together, and that means our answer here is C. So I hope you found this helpful. If you did, please make a comment or leave me a comment, and if you have any other videos you would like me to do or examples, just let me know in the comments. Thank you for watching. Bye.